Hey guys, coming at you live from a different location today. I am in my dining room, so apologies now if my cat walks in front of the camera or if he lays on my paper at any moment, but it's good to see you guys. Today we're going to be logging in and looking at lesson 1.2.2 in our ebook. So open that up for me and we can get started. So today our question is, how can I investigate a function? What does it mean to describe a function completely? In this lesson, you will graph and investigate a family of functions with equations of the form f of x equals 1 over x minus h. As you work with your team, keep the multiple representations in mind. So today we're going to be digging into tables and graphs and looking at how they match up with an equation. Today, the first problem we're going to look at is 1-78. I'm actually going to do this one with you so you can kind of see how this function works. And then you're going to try to investigate in a similar way using a different number. Today, we'll investigate functions of the form f of x equals 1 over x minus h, where h can be any number. So, for example, I'm going to use the value h equals 7. So when you are doing your problem, you cannot use 7 because I'm using it here. So my new function is f of x equals 1 over x minus 7. Today we are not going to be using Desmos or graphing calculator. We're going to do a little bit of graphing by hand so that we can see some trends and make some conclusions. You will go back to using your calculators, but just for today's investigation, we're going to put those to the side. So this is our function that we're going to use here, and I'm going to make an XY table with, I'm going to try at least 10 points or so I can really get an idea of what this graph looks like. So let me create my XY table. If you read a little bit lower, they will give you an idea that you should take your number here, so 7, and subtract 5. And that will be your starting x value. And then if you add 5, that should be your ending x value. So I'm going to go from 2 to 12 to kind of get a good idea here. And 5 is like that magic number to get half and half. So I'm going to do 2, 3, 11, 12. Okay. So I'm going to look at these points here. So remember, when you are figuring out what the y is, you're just plugging your x into your function. So for this first one here, I'm going to kind of do my scratch work on the side. I have 1 over 2 minus 7. So that means I have 1 over 2 minus 7, which is negative 5. So this is negative 1/5. And that's okay to graph because we know that's going to be part of the way between 0 and 1. So we'll estimate when we do our graph. Then I have 3. So 1 over 3 minus 7 is going to be negative 1/4. This will be negative 1/3. I'm going to show you another one here. So let's say we got 1 over 5 minus 7. That's going to give me negative 1/2. So I'm just plugging in these x values into my original function, and that's how I'm getting the y value out. This one's going to be in negative 1. Okay, now I have 1 over 7 minus 7. Okay, 7 minus 7 is 0, so I get 1 over 0. Can we divide anything by 0? So remember, it's like if I have one cookie and I want to divide it among 0 people, does that make sense? No. So this is what we call undefined. So we won't graph that because you cannot divide by 0. If I do this, 8 minus 7, I'm going to get a positive 1. 1 over 9 minus would give me a positive 1/2. Positive 1/3, 1/4, and 1/5. Okay, so these are my values that I have here. If we take a look, do you notice anything about our y values? So I noticed that we have a lot of fractions for both parts, which is okay. We can graph fractions. We'll just have to estimate. I also noticed that on the different sides of our 7 here, which is the number here, they mirror each other, right? So it's like we had a positive and a negative, a positive and a negative. So that will be interesting to see how it looks when we graph this thing. So when we are looking at this undefined part here, we're saying at this point we have an x value that has no y value. And that's okay. That just means we can't plot a point there. So I'm going to take my graph here. I made a little XY chart. And I made my x-axis, I labeled it 1 to 12 because I'm using whole numbers for the x's. But then for the y, I skipped a couple and did 1, and then skipped a couple and did -1 so that I can plot these fractions in here. And I'm already on a good start to a complete graph because I have my axis labels and I have the scale written down as well. And you're allowed to have a different scale on your x than your y as long as you keep it consistent. So my first point was 2 -1/5. So I'm going to go over 2, and this is about, I'm going to put a half in here. Okay, so I know a 1/5 is going to be like way up here, like 1/5, okay? And then I have 1/4, which will 3 1/4, which would be a little bit higher. 4 1/3, 5 is -1/2, so that's going to be about right here. And then 6 jumps to -1 here. So that's what part of my graph looks like so far. Let's get it down to see it better in the light here. Okay, and then I need to graph the other half here. So 7 didn't have a point, 8 was at 1. So I have that here. Okay, and 9 was at 1/2. We have 10 and 1/3. And then 11 is going to be 1/4, which would be about here. 12 is 1/5. Okay, so this is what the graph looks like right now at this point. So we can see that there's something going on here, right? So it's getting really close as it gets to the x-axis. But then when it gets to the 7, the numbers are getting bigger, right? But 7 isn't an option. So we're going to start looking, we're going to look at some decimals to see if we can figure out what trend is happening as we get closer to 7. Try some decimals that are close to 7, and we're going to look at both sides. So I'm going to choose 8 input values that are very close to my value of h and on each side of h. So for example, I'm going to work with 6.5, 6.7, 6.9, 6.99. So see how I'm getting close to 7 in the one direction, and I'm going to go over 7. So 7.01, 7.1, 7.3, and 7.5. So from the left side, I'm getting closer, and then if I come from the right side, I'm getting closer. And again, we're going to plug these into our equation, and we're going to round a little bit so we can see what our value is. Looking at our decimals now, when I plugged in 6.5, I got -2 as my answer, or my y value. When I plug in 6.7, I get a -3.3 or 3 1/3. When I plug in 6.9, so I'm just going to show you one more time, I get a -10. And then when I plug in 6.99, I get -100. So I can see that these numbers are getting bigger and bigger in the negative direction. Okay, so let's look at what is going to happen now from the other direction. So if I have a 7.01 and I plug that in, I'm going to get a +100. I'm going to get a 10, a +3.3, and a +2. So again, my numbers are mirroring each other, but this time they're going to get bigger in the positive direction. So I'm going to toss these numbers on my graph here so we can see what I'm looking at. So I've got my graph. So if I were getting close to 7, so I'm going to do a 6.5, that's going to be here at 2. 6.5 is down at 2. If I were to do that 6.9, I'm going to be way down at -10, which again, I'm just estimating. And then if I did the 6.99, it'd be like way down here at 100. But you can see it's getting really, really close to this 7, but it's never going to actually touch 7 because my numbers just keep getting bigger and bigger. And same if we would go in the other direction. So if I did like 7.5, I'm going to be up here. If I did 7.99, I'm going to be way up at 100, right? So again, I'm getting really close to that 7, but I'm not actually touching. So the shape of this graph, if I connect my dots, looks something like this. And this is the general type of form that you're going to notice when we're working with a graph that is f of x equals 1 over x minus some number. And whatever that h value is your number that the graph will never actually touch. And that makes sense because whatever number we plug in for x, we would get a 0, and we can't have any value here. So what's actually happening is there is a line here, and we always put them as dashed lines because it's not a line with points on our graph. It's actually a line that's saying like, this is a blank, there is no points that will fall here. And we actually call this an asymptote. It's spelled kind of funny, but this is an asymptote, and we're going to learn about those more as we work through lesson 1.2.2. So this is kind of what you are going to be doing, but choosing a different number. Please use this as an example. So you're going to create a long list of numbers and some key points. Remember, in your initial table, whatever your number is, do 5 less and then 5 more, and that will create your initial 10 points. Then you're going to put some decimal points in that get really, really close to whatever your undefined number is. So give this a shot. I'm going to let you try it on your own, and you are going to do a flip grid to show me your work.